Hey guys, welcome to DSA-n-Design. Today we will look at how to find the mid node of a linked list, right? So what we want to do is we want to find a mid node of a linked list. All right? Let's try to understand basically what it means, right? So for example, we have this particular linked list. We have, let's say, 4 nodes, and this particular, and this is my head. Now value is 10, 25, and 6, for example, right? Now, when I say, and there is another one, let's say I have one more, all right, one more where I have 5 nodes in this case, okay? The even number of nodes and odd number of nodes. We will try to understand what exactly I mean to say when I say mid node, right? So here, let's say 5, 10, 20, 30, 40. This is my linked list 1, for example, and linked list 2, all right? Now, this is obviously even length linked list, right? We have 4 nodes, right? In this case, my mid node, right? My mid node should be basically size divided by 2 minus 1. This should be my index basically. So, okay, so what will be this value? Basically 4 by 2, 2, basically 2 minus 1, actually first index. So when I say index, it will always start from 0, right? So 0, 1, 2, and 3. All right. So when I say mid node, I actually mean to say, okay, let me take this color so we can. Okay. So when I say mid node, in this case, this is my mid node, guys. Okay. Why? Because this is odd, even number of nodes are there in this linked list, right? And then this is basically the formula, right? And in case for odd, what we do, like we actually simply do size by 2 and whatever index we get, right? That is going to be my mid. So in this case, let's say 0, 1, 2, 3, and 4. Here I have 5, right? 5 by 2 equal to what? 2.5, which is basically 2, right? Integer value of this 2. So actually I want to return this one, so this particular node, right? And obviously if you see, there are 2 here and 2 here, so if the linked list is like odd length linked list, right? And in this case there is no problem, right? We just go to the mid because we will find one mid, and then there will be equal number of node left and right. So here there is no issue, but here basically generally, like in the question, they will be telling also, right, what exactly you want to return, whether you want to return size size by 2 minus 1, or maybe size by 2. So in they say size by 2, and then in that case it will be 2 basically. So this index actually we have to return, right? But I mean, you just go based on that, you clarify it, right? When you go for kind of interview, then you actually clarify what exactly do you mean by the mid node in case there is a even length linked list, right? So we are assuming that this is what exactly we want to achieve now, all right? So generally, as I said, this is the first approach, right? What exactly I will do? I'll go and count the total size, and then I will just divide, and then again I will actually start traversing from 0, and I'll go to again I'll go to that particular index, and I'll return that index, right, in that particular node, right? But this is kind of, you are actually traversing the linked list 2 times, right? Which is kind of, one time you are just counting, and second time you are again traversing and actually going to that particular node and returning it, right? There is another way, right? Specifically in the linked list, right? So this is basically way 2, right? Way 2. In way 2, what exactly we use? We use actually 2 pointers, right? So 2 pointers. One is basically slow pointer, and another one actually fast pointer. We'll see what it means. So slow pointer basically will actually move 1 step, all right, and fast pointer will move 2 step, right? We'll see what it means, right? And then the moment I reach to the end of the linked list, right, I will actually simply return the slow pointer. Let's try to understand what it means, right? And I think it will be more clear. Concept is more important here, guys, right? So let's say, for example, I have uh, I have this linked list, mm, this linked list. Okay, all right. Maybe I'll take 2 more. Okay, 6. Total 6 nodes, and the value for each of this node is, let's say, 5, 2, 3, 8, 10, and 15. All right. Now this is my head, right? What I will do is I will say fast and slow I'll put here actually. This is my fast pointer and this is my slow pointer. I'll start at the head itself, right? And what I will do, I'll move fast pointer two times, right? So let's move fast pointer two. So I will actually move one, two. So here will be my first time, and my slow will be moving one step. So I'll be here, right? Now again fast will move to two here, and then slow will okay, and slow will move one step. So it will be here basically, right? Now you see that when I move again fast 2 and it will actually go to null. It will where it will go? It will actually point to null. So I actually don't want to move my pointer. The moment my fast dot next or fast dot next because we are actually moving two step, no? If I am actually moving outside, actually my fast pointer is going to point to null, and that is the moment I will stop. Okay. Now obviously in this case when I say fast dot next, right, this is how I move to step, right? And if I say f, then my f is actually going to point what? It is going to point null, and this is the moment I will not enter my, I mean I will not actually, I'll stop my for while loop, right? Now another case could be, okay, in case like this is for the kind of uh, even number linked list, right? Even number node linked list, right? Okay, for example, in this case, let's say if I'm actually my fast is going to move outside this linked list, then I'll just return slow, right? So if I return slow, if you see, if I return slow, what exactly I'm going to return? I'm exactly going to return the mid. This is mid, right? So I'll just say return slow. This is my pointer, and this is exactly fitting correct. Okay, and this is what the approach in case I have the linked list which is having even length, right? So this is for the even length. All right, even length linked list. Now let's try to understand how it works for odd length linked list, right? So I'll take another example here. For example, I'll take let's say I'll take five nodes. Let's say one, two, three, four, five. All right, guys. So let's say this is my head, right? And this is 10, 20, 30, 50, and 40. All right. Now let's say I actually say my slow is here and fast is here. Let me, okay. Slow is here, fast is here. Let me take different color, okay? Now I say my fast will actually move to, so my fast will be actually this one and this one. My fast will be here. Now my slow will be moving one, so my slow will be here, right? Now my fast will be moving two steps, so I'll be here actually, and now slow will be here, right? Now you see, I actually reached to the end of the linked list. So here another condition could be the moment I actually say I move actually two step, right? So when I say fast dot next, I'm actually outside anyways, right? In this case, actually, I don't want to go. I mean, I will not be able to move two steps anyways, right? So I can actually move one step. Let's say fast dot next. The moment I say I don't have any more nodes left after this, which means if my fast dot next is pointing to null, I will stop there actually. Okay. I will stop there. So in this case, if you look at it, the condition comes out to be if my fast dot next equal to null, right? I will stop it here and I will return slow again. I'll return this. So this is my mid. So you see that there are two nodes here, two nodes here. In this case, I'll return just mid, actually return S, which is slow pointer. So exactly, you see that I will actually stop my pointer. I mean, basically, I'll stop my loop the moment I say fast dot next equal to null R, okay, or end basically, right? Either of this condition, if it is either of this condition is false, let's say fast dot next. In this case, my pointer was here, no? So if I say fast dot next, in case it is even length, in that case also I'm going to stop my pointer and I'm going to return slow, right? So hopefully you understand. For so what we conclude is basically for even length, right? For even length, one second. For even, no guys, one second. All right. One second. Give me a second, guys. Okay. Something is wrong actually. Okay. So let's say for even length, what I'm going to say, I'm going to check fast dot next. If it is null, then if it is not null, until it is not null, I'm going to continue to move. And for odd length, right? We looked at it just now, odd length. I'm saying fast dot next. The moment it is not null, until it is not null, I'll move. The moment it is null, I'll stop it, right? So this is how we can do, right? So if you look at the code, right, how exactly we can do, right? So for example, I will just return the head node, right? After that, basically, no, I'll not return head node. I will rather return the mid node, right? So let's say I say node, right? I will say node. One second. I'll just code it here. Okay. The code for this is going to be something like this, guys. All right. I'll say node. This is what I want to return, no? And I want to say no. Okay. One second. Node and function, right? Mid node actually. I want to return the mid node, right? Now I say node and I have the head, right? I know the head. Now what I will do is I will just say, okay, I will kind of say I will just make a slow pointer as head. I'll start basically same, right? And I'll also start my fast also at the head itself, right? Now what I will do, I'll put a condition. I'll actually continue moving until my fast dot next is not null and right and fast dot next, you see, is null. Until these two conditions are true, right, I will continue to move, right? So because these two conditions came out of this even length and odd length, right, that we have just seen it, right? Until that I'll keep continue moving, right? Now what I will do is, I will just move my slow actually one, right? So I'll say so slow equal to new slow will be slow dot next and fast will be what? I'll move two steps, right? To fast dot next and dot next. All right, and this is the end of this. And the moment one of this is false, I'll come out of it and I will just return. What I'll return? I'll say not fast, guys. I'll return just slow. And this is going to be my mid node. All right. So this is what exactly we need to do. Let's quickly try to see in IDE and then see that it's working fine. All right. So let's try to use the same kind of what code, right? Let's try to do it, right? So let's say I'm just creating a function, public static, and I'll say I'll return the mid node, right? So node, and what I say, I'll say mid node. All right, same thing. I'll just take node and I'll take head here. Okay, head here, and I'll say node slow. Slow is actually head and fast is also going to be same actually, right? Slow and fast is going to be same initially. Okay. No, okay, sorry. This should be fast. Now, what I will do, I'll just put this condition until fast dot next is not null and fast dot next because this is two step is not null, right? What I will do, I'll then come out inside. If it is true, until this condition is true, I'll come inside and I'll just continue move. So one step for slow and fast will be moving two steps, right? Next and next. All right. And the moment it is false, then I'll come out of it and I'll just return slow pointer. This is all done, guys, right? Now let's try to test it. Okay, so I just want to get I have this linked list, right? Okay, this linked list, I have 5 nodes basically. What I will do, I'll just say Okay, I'll just take the mid node actually. So I'll say mn, I'll just take it head. All right. Now what I will do, I'll just print this, right, value. If I can just print the value, then I'll know that whether I am actually trying to, I got the, so mn, this is mid node. I'll just say value, right? Then in that case, I'll come to know, right, whether I'm getting the correct value. Let's try to run it, guys, now. Okay. So ideally, I should be getting what? 10 in this case, no? Okay, where is the problem? Oh, here. Okay. All right. I'm just trying to run it. Let's see. Okay. See, I got 10, right? Which means I'm able to return the head node here, right? Head node is basically I stored in mn and then I just printed the value of it. Correct. Now let's say I have, let's say, okay, 4 node actually. In that case, 4 node, it will be 2, 5, 10 and 12, right? I am not actually linking the last node, which is 50. So it is the linked list is 2, 5, 10 and 12. Okay. So in this case, I should be actually getting 5 here, right? Because 4 divided by 2, if I say it's 2 second index minus 1, it's basically first index. So this is 0 index, then this is first index. That's what we understood, right? Let's try to see if it is returning 5 value this time. You see, this is working fine. Okay, so this is, guys, this is how actually you can return the mid node, right? And we will actually see the application of this node in the next video, right? When we will try to arrange a linked list, right, in a certain way, and we will be actually using all these concepts going forward, right? Because what we also learn how to reverse a linked list, how to actually return, how to merge the linked list, right? Two linked list, sorted linked list, how to merge this two list. We just learned before this, and this time we learn how to actually return the mid node without traversing the whole of the linked list and getting the size and all those things. Using the slow and fast pointer concept, we actually learn how to actually return the mid node, right? We will be using all these concepts going forward, guys. So that's why I say that if you have not sure how to I would suggest go and revise those previous topics as well, like reversing linked list and also how to merge two linked lists, etc. Okay, we'll be using this concept going forward. That's all for this video. I'll see you soon with the next video. I hope that this video is helpful to you. All right, bye.